All right, we're going to go ahead and get started. I'd like to thank everyone who is joining us today. Welcome to today's CNCF webinar, introducing Trackman, an open source tool to sequence application deployment to Kubernetes. I'm Caitlin Barnard, Marketing Manager at CNCF, and I'll be helping to moderate today's webinar. I'd also like to welcome today's presenter, Kash Sajati from Cloud66. So just a few housekeeping items before we get started. During the webinar, you are not able to speak as an attendee, so there is a Q&A box at the bottom of your screen. Please feel free to drop any of your questions in there throughout the webinar, and then we'll get to as many as we can at the end. The session is being recorded and will be sent out afterwards along with the link to the presentation. So with that, I'll hand it over to Kash to kick off today's presentation.
Thank you. Thanks, Kitty. Hi, everyone. My name is Kash Sajati. I work for Cloud66. And today I wanted to share with you an open source project that we've been working on for a while, and we use it internally called Trackman. But before I get to that, I will tell you a little bit about the other open source projects we have, which we've used this forum to introduce to fellow Kubernetes and CNCF developers, and a little bit of background about why we had to build Trackman, and hopefully you'll find it useful as well. So, as I said, I work for Cloud66. I'm primarily looking after the product part of things at Cloud66, and we usually we have a couple of products, actually 4 products that we sell as a service. But when it comes to open source, we are a company that produces open source projects either for the community that we are active in, or just as internal tools that we have, and we wanted to share it with other people. So what we do is selling products. Our products help small businesses to with their DevOps mission and organizing their infrastructure in a way that if they don't have an army of SREs or ops people, our products are very useful to them. But the open source part of it is only projects that we share. We are not an open source company, and we don't make money from this. And the reason I'm saying this and iterating on it is that because I know that there's a lot of sensitivity around pitching our products, and any vendor using an open source platform or a forum like CNCF to pitch any products. Frankly, these open source projects we have are sponsored by Cloud66. We usually use it internally, and we do that just to get problems solved for other folks around as well. So with that, some of the projects that we've rolled out before, and Trackman is the 5th one around that. The first one was Starter, which is a small tool that reads the code in any code base and tries to understand the framework, the language, and some intricacies around each one of those frameworks. And from there, it starts to get Docker file and some other artifacts generated based on the source code, things like some Kubernetes manifest files, and we get to that a little bit later. The second one was Habitus, which is a build workflow for Docker. It does 2 primary things. One is to create a step-by-step workflow for Docker around building one step after another, which you can also do with multi-step builds in Docker. But another thing that a lot of people find useful that Habitus does is that it allows injection of secrets during the build process of Docker images, which sometimes is very useful when you have private repositories, when dependencies like NPM or Ruby gems or Nugget, that you want to have dependencies that live inside of places that require secrets or API secrets for some parts of the build. And Habitus is a good tool to use that without leaving any secrets left behind in the image. Copper is our 3rd product that we rolled out, and it's like a unit test for Kubernetes. It's got a very simple DSL that you can write. It runs on your Kubernetes YAML files or manifest files, JSON files, and then makes sure that they comply with rules that you set. So you can think of it as an FX cop for Docker, for Kubernetes manifest files. Ultrant was the last one that we rolled out a while back. And you can think of it, if you're familiar with XSLT, which is a conversion language around XML, it's kind of the same thing, but for YAML. And it's not as difficult to use as XSLT. It uses JavaScript. So you can write JavaScript to transform one YAML file to another one. And I can touch upon that a bit later as to why that's useful. And the last one, which today I'm going to show you, is Trackman, which is a command sequence management system for Kubernetes. I mean, technically it can be used for any sequence of commands, but we built it for Kubernetes in mind because we had certain problems we needed to solve. So starting with Starter, you can find it at www.startwithdocker.com. And this is just a screenshot, a very quick screenshot of what it does. So I'm running Starter against a, I think here a Ruby or Rails probably code base. And what it's doing, it is detected that I'm using MySQL, I'm using Redis and Elasticsearch. It's detected that I'm using the latest version of Ruby. And from there, it's going to analyze, generate background and foreground processors for me, generate a bunch of Docker files. And in this case, I'm using it to generate Docker Compose as well. So from no container-based application, I end up with something that can get me started. It obviously generates those files, and you can take it from there and then enhance it and modify it and augment it. But it's a good start. And that's what Starter is. You can check it out at www.startwithdocker.com. The second project is Habitus, as I mentioned. So there you can see at the top, I have one step build. It's just the build part using a specific Docker file. But what's interesting there is a couple of things. One is that you can then pull out the artifacts of that build from within the image, which can be used in the next step, but also more importantly, sometimes I've seen people use Habitus to build projects within a specific environment that they don't have available on their laptop. For example, they're running a Mac and they want to build something for a specific framework or architecture, and they do that inside of a Docker image, and then they pull out the artifacts as just binary files and then upload it as part of a release process, for example. The second thing that you see at the bottom is a snippet of a Docker file with an argument host generated. And you see there that I'm running a wget, or you can do a curl, that is hooking up to a host, which is the binding, the port for Habitus itself when it's running. So from within the Docker build, I'm actually doing a curl outside to Habitus to pull out a secret, a private SSH key in this case, and then run, for example, some connect to GitHub, to my private repository, and within the same Dockerfile line, I'm removing that file so there's no trace of it in that layer. And that's a very safe and secure way to use secrets during the build, but not leave them as sometimes you end up forgetting to, for example, delete them, or you leave it as a layer in the image, and that's what Habitus can be very helpful with. You can find Habitus at habitus.io. Copper is the third project. So as you can see, it's got a very simple DSL. And what it does is around making sure that you can set up rules, things like don't use the latest image on your Docker file. And if you're familiar with the Docker manifest file, which I'm sure you are, you'll see that I'm doing a fetch of all the images that I have on all of my containers. For example, in this case, it could be a deployment. And Copper understands the syntax of an image, a Docker image. It therefore can interpret that string, the image string, as an image. I object, take the tag out and make sure that it doesn't contain latest. And we all know that using the latest is not always the best practice. And you can just run it with a Copper check, and it will return a status of non-zero when it becomes, when it fails. And you can have lots of these rules to either ensure something or warn you around it. And then you can have these rules dovetailed right after the files are produced with your pipeline or CI/CD, and then before they hit the cluster, you can make sure that they comply and conform to your rules and things that you need. You can find it at cloud66.com/copper, and I think we talked about this before. Altrunt, on the other hand, is a simple way to convert YAML files. And this is a very simple example because this session is not about Altrunt, but here you can see that I'm using JavaScript, a very simple JavaScript snippet that adds an annotation with a deployed at to any service that I have in my Docker file. So $$ here is like the $2 signs there is always loaded with the file, the YAML file that you load into Kubernetes. And then I'm going through each section, each one of those. If you have a multi-party YAML, for example, If it's a service, then I'm just going to add an annotation to it. And in this case, it's an annotation that's dynamic. But you can imagine that we've used this to inject Istio, for example, into any deployment that we have going and hitting our cluster. And the reason we use this as opposed to operators or any other way of doing it, which are similar ways, is that we want it to be transparent. So we know, first of all, it's version controlled. So we put these files into Git repository, but also we want to make sure that we can inspect the artifacts that it generates, and then we put those into a Git repository as well, and then we apply it within our normal CI/CD pipeline to make sure there's no magic happening behind the scenes, and all clusters are just vanilla Kubernetes clusters across the scene, regardless of their environment. And that's Alterant. You can find it at cloud66.com/Alterant. Now, Trackman. So Trackman is the latest open source project that we rolled out. And so what is it, and why did we need it? So as part of our deployment of own Cloud 66, so Cloud 66 itself is delivered as a SaaS, and we roll it out as a Kubernetes installation. So it goes out to multiple Kubernetes clusters and delivers its service to our customers. And as part of that, one of the things that we wanted to do was to make sure there's a sequence of things running when it hits the cluster. For example, sometimes we have a database migration that we need to do before the code goes out. Now, most of the time, those database migrations are backward compatible. So while the database migration is happening, you can still run the old code and you can run the new code. But once the new code goes, the new database is migrated, sometimes we need to then make sure that migrations happened, everything's okay, database schema is in correct shape, and then we can roll out the next step of the deployment, which is the application itself. So if you think about it in terms of Kubernetes language, you might put your database migrations, for example, in a Kubernetes job. And then your application is obviously going out as, I don't know, daemons, replica sets or deployments or stateful sets or whatever you have over there. You need to make sure that there are two files, for example, that you use against kube control. The first one will deploy the job, and the second one will deploy your deployments. But you want to make sure the second one is always happening after the first one. Once it's out, once it's complete, and it's successful. And given the fact that Kubernetes runs in an asynchronous manner, just running a kube control apply my job is not going to guarantee that, first of all, the job is going to succeed, is completed, so I can do the next thing. We could have done this with a simple bash file, but frankly, nobody in the company is a fan of bash files. That's the first thing. The second thing, we want it to be developer friendly. We want this to be something that we can just roll out and have a single file that would run a bunch of commands on your machine, and it will deploy the entire application on Kubernetes without doing anything custom. So with that, I'm going to share my terminal screen just to show you a quick demo of this. Okay, so here I have a job, a simple job here that's calculating the number of the pi value of pi. I think up to 10 digits, and it takes about, on my laptop, it takes about 10 seconds or so. What I want to run this as a job, make sure it's complete, and then clean up after myself. So normally, if you were to do this on a Kubernetes cluster, I think I have a mini kube here. Okay, I don't have anything running. I start my job, and then this time I'm just using it normally. As you can see, it's running. I'm just going to put a watch on it. All right, it took 11 seconds, give or take, to complete the job. Now I have the job, and I think I should have a pod as well, which is defunct now. It's just completed. I'm going to delete it manually. Now I'm going to use Trackman to run this. Now, for the first step, I'm simply going to have one step that just does a run with kubectl apply, the same command that I ran. So that's the simplest format. I need to just run it within the right directory. Okay, so what I've done now is I just ran the job and it was asynchronous. So as you can see, it's still running. We'll take another couple of seconds to finish. Yeah, so it's done. Now, nothing very exciting here. We just ran the job. Now let's take it one step further. So what I do now is I want to define what we call in Trackman a probe. So I want to run the job and I want to wait for up to 1 minute for the job to finish. This is just the equivalent of running this and then running a kubectl wait for the condition of this job to be complete. Again, very simple, but hopefully useful. So here now I'm running the job, I'm running the probe, and within 10 seconds or so, this should finish successfully. Probably I didn't set the timeout correctly. Well, now it's ran the previous job. Yep, job's finished. So as you can see, if I do this again, I'm running the job itself and I'm running the probe. This time I'm going to run it with a log level of debug just to see what's going on. Okay, so condition met and it's finished. So now I have the job running, but still there is the pod that's left over. And if I run it again, as you can see, it would bounce back very quickly. So in order for me to run this job over and over again, if it's a regular job, for example, I need to clean up after myself. And then here what I can do is I can say there's another step, and that's the cleanup of the job. And this depends on the previous step run. If I don't mention this step, depends on, it will try to run as many jobs as it can, or as many steps as it can in parallel, depending on how many cores I have on my machine. And then if I have any dependencies, it will basically build a graph to which ones depend on what and how many it can run, try to maximize the speed of this run. So it can get a bit clever in terms of how many jobs it can run. But let's just keep it simple here. So here, I just ran it and I'm waiting for it to finish, and then I cleaned it up. I'm going to run it one more time. Just before I do that, let's just see if the job is there. Now it's deleted. If I run it one more time, I think I need to set the timeout a bit. Okay. So now I had the cleanup job running. Now, one of the things that we've seen is that, yeah, there's no job. One of the things that we've seen is that if I give this to someone and they don't have kubectl set up, for example, then it's not going to be any good. I might not always have kubectl here. I might have other things like Helm charts, for example. I need to install a Helm chart, and you might not have Helm installed on your machine. Or I might want to make sure that not only do you have Helm, but you have Tiller installed on the cluster that Helm's connected to as well. And those mean that you can have some pre-flight checks here as well. So in this specific case, I've done a simple kubectl version, which here I'm relying only on the value of the exit value being non-zero, and that is good enough for me. So I know that you have kubectl installed on your machine, but you can go further and check the version to make sure that you have a specific version of kubectl or anything else that you might want to have check as a pre-flight before you start running this step. And for that, what I can do is I can just run this guy. Here you see that I'm running the pre-flight for that step, which now runs and returns the version of just the output of that command. Then it runs the probe, the command and the probe and the cleanup and everything in one go. So technically what I can do is I can just give this file to someone and they have Trackman installed and they will be able to just deploy something after another. So that's kind of the basics of what Trackman does in a nutshell. But there's a lot more inside the tool that can take care of things. You can have metadata, obviously, like any other Kubernetes asset. But as well as that, you can use that metadata to manipulate the commands that you run. For example, in this case, I have a step that just checks the arguments of something. I can set the work directory, but I can also get the value of this specific metadata, which is this string, and pass it into my command. This way, I can have a fixed command with different metadata and run different types of commands. I can continue on failure and very simple things I can do. We also do replacement of environment variables, various different timeouts. And as you can see here, I can have multiple dependencies between different steps. So this step, for example, is called false. It runs the command false. Obviously, it's going to fail, but it does that after waiting for two other commands to finish first. And in this case, because I'm not running some of these commands as dependencies, I will end up with, in my case, I think 3 commands running in parallel because I have 4 cores on my machine. So we run the number of cores minus 1 number of jobs. And that's how we calculate how many jobs to run in parallel, but also wait for everything else. That's a very simple way for Trackman to run a sequence of commands. It's a very simple tool, nothing really magical about it, apart from developer experience. So what we've seen is that instead of, if you wanted to deploy the entire stack, for example, of an application that you have, usually what you have to do is you have to run a bunch of things once. For example, things that set up your cluster. Things like the credentials to your Docker repository is one. Setting some parameters around RBAC on your cluster is the second set of things that we run. And once those are finished, and those are the things that we run only once, but there's a sequence of those, then the second batch of things that we run are usually around some Helm charts, for example, that will deploy basic components of our application, like databases, MySQL, Redis, and potentially some ActiveMQ, NATs, or other things around messaging. And then we get to the crux of it, which is the application itself. Now, sometimes you might bundle your application into a Helm chart. We bundle it into something we call a formation. But regardless of that, if you use Customize or anything else, you will end up with multiple steps that you have to run. And one thing that we wanted to do is to make that also predictable and as repeatable as Kubernetes application, Kubernetes manifest file itself. On Kubernetes, you have the same file that you can run over and over again, and it's great. But then we don't have the one level above that, which is a sequence of other things that you need to run in order, in the right sequence and in the right order, to end up with the entire stack to be deployed. And that's why we created Trackman itself. You can find Trackman on GitHub Classic 6 OSS, which is our open source project repository, or project home. It's written in Go, so it's a very simple thing to install. And it also supports a bunch of other things around automatic updating and different channels that it has. So you can be on an edge or stable or the development channel, and just make sure that's always up to date. I think it updates itself as well as every time that it runs, which is great if you want to roll it out across the fleet of your of the machines within your company. So just deploy it once with your fleet management software, and it keeps itself up to date. And it will allow you to just have a single place that the deployments of your entire stack lives on. Something that you can then do with a simple command, for example, around you can run it across from a specific place. For example, get a curl from some local repository. For example, some my stack, and pipe it to this, and that's all the commands that I need to run to get everything going from the first step to the last step to have my entire stack deployed. That's just a very quick intro to Trackman. As I said, we built it for ourselves to make sure the entire stack is deployed every time in a predictable way. But we've also released it as an open source tool. Another thing that you can do with Trackman is you can use it as a Go library, not just as an executable. You can include it into other projects that you have as if they're written in Go as a library, and it's fully capable of taking care of executing everything and taking care of the processes, killing them within the library itself, so you don't need to worry about those things within the application that you're running. That's all I had to say about Trackman itself. At this point, if you have any questions, I would love to answer them.
Awesome. Thanks, Kash, for taking us through Trackman. So if you have any questions, the Q&A tab is at the bottom of your screen. So feel free to drop any in there, and then we'll get those over to Kash. All right, we've got a couple questions here. So any future plans for asynchronous tasks?
At this point, we have the asynchronous nature is slightly difficult because the tool is written in Go. So as you know, running processes with Go that are asynchronous are not as it's easier. It's much easier to have. Let's put it this way: it's much easier to run a synchronous task process with Go as opposed to just letting go. So one of the options is to keep Trackman alive while the asynchronous job is running. But then again, the whole purpose of Trackman was to make sure things happen in a predictable way. So the fire and forget would have kind of defeated the purpose in that sense that we wouldn't know if the deployment's gone through fine if we were to do it asynchronously. However, this doesn't mean that we cannot make it asynchronous and just have a fire and forget. At this point, we don't have any requirements. I would love to know if you have any specific use cases that we can do this, and definitely we can look into it.
All right, another question here. So how is Starter different than S2I of OpenShift, or is it similar?
I think it's similar in many cases. It's the only difference I would say is that it's very generic. It's not specific to Kubernetes or container-based nature. You can think of it as a very generic way of running steps after each other in a predictable way, and take care of it that way. Apart from that, there's not much in philosophy. Basically, they're very much the same. We want to have something that's more generic because we just don't use it all the time for Kubernetes. That's the only difference, or containers for that matter.
Great. I'm going to leave this open here for any more questions for a few more minutes here. If there's anything else we can answer for you. In the meantime, is there a place, that was the slide I was looking for, where everyone can go if they have questions after the fact as they start diving in?
Definitely. I'm just going to put that into the chat session for everyone. If I can figure out how.
We have another question here too, as we're sharing that information. So Helm automates application component deployment, and Trackman seems to be automating what Helm does and more. Is that correct?
Yes. Usually it's mostly around So there are a couple of things here. One is about Helm. To answer your question directly, yes, that is correct. Trackman sits on top of other things. We use it for Helm. Part of the steps are Helm, and some of them are just pure kube control, things that we deploy. But there is one specific thing about Helm, and I briefly mentioned that we use formations instead of Helm for our own application deployment, is that we use Helm for application package deployment, not for application deployment, for package deployment, because we see Helm technically as a Kubernetes package manager, the same way, for example, NPM is for Node.js, or RubyGets or gems are for Ruby. And I know that you can, if you want to, you can package your entire application into one or more Helm charts and releases and use those for that purpose. But I think Helm lends itself much better to package management, when I can go and get off-the-shelf components around, I don't know, a database or some open source component that I want to deploy to my cluster or try it out, or have it simply installed on my cluster, like certificate management or external DNS providers or other custom resource managers like Argo, for example, for workflows. And Helm's great for those things. When it comes to application, we found it not as fully powerful as it is as a package manager. And I think that's why a lot of other things have been merged into, for example, kube control, customize is one, and other ones that are specific about application management. We tend to use formations, and as a result, Trackman sits on top of those things, and Helm is part of the bigger chain where it deploys the basic components of the application, but the rest of the things that it deploys are going through, for example, formations or kube control directly themselves.
Awesome. So I'll give everyone a last chance if there's any other questions you would like us to answer. Otherwise, the information and all of the links are now in the chat, and they'll be available in the slides when we send those out, in case you have any more questions or want to get more information once you start diving into Trackman. So with that, I think I will close this out for today. Thank you again, Cash, for the great presentation. And the webinar recording and slides will be online later today. So we look forward to seeing you all at a future CNCF webinar. Thanks, everyone.